This is question 24 from the mid-semester test, and it's a slightly tricky question, and it certainly tricked me in the mid-semester test. Hopefully it didn't trick you. A printing shop supplier advertised that its cartridges are 200 grams, and we're doing a hypothesis test at a 5% significance level based on a sample of 300 toner cartridges to determine if the true mean net weight mu is less than 200 grams. So we're doing a hypothesis test here. And H0 is going to be that mu is equal to 200, because that's what they stated that the mean would be. And we're testing H1 that mu is going to be less than 200. Oops. So you can immediately wipe out answers A and B. So now we just needed to determine whether or not we were going to reject it. And you could easily convince yourself here with alpha is 0.05, we got n is 300. You could easily convince yourself that this test statistic is a Z statistic because we've got such a large sample size. And so the question is, with a Z of 1.97, do we reject this hypothesis or not? And if you go and look up 1.97 in the tests in the Z tables that you're given, and we go and see, okay, 1.97, that's going to give us a probability of 0.9756, or a mean of, a probability of 0.9756, that the mu is somewhere beneath that. So in theory, you would say, you could easily convince yourself, yes, that's extreme enough to reject that the mu is equal to 200, but the problem here is we've actually rejected it in the wrong direction. We've now said we have satisfied the hypothesis that mu is not equal to 200 with a 5% confidence, or a 5.05 alpha, but we have not rejected H0, that it's less than mu. And that makes perfect sense if you remember how the test statistics calculated, because that's going to be equal to our x bar minus mu divided by, well, depending on whether or not we've got the variance or not, but the standard deviation or not, but let's say we do. So basically what we're saying by saying that we've got a test statistic of 1.97 is that the sample that we took had an average greater than the mean. So obviously we're not going to reject the hypothesis after one sample that finds a sample mean higher than the average that they were suggesting. So in fact we do not reject the null hypothesis. We don't reject it. But if you had just looked at the 1.97 and said, yep, that's extreme, you might have, as I did, come to the incorrect conclusion that we're rejecting H0, because actually we've proven that at that confidence level it's probably higher than 200.